Welcome back to part 5 on quadratic functions and modeling. In real life, whenever we're using quadratic functions, their max or min are very important. For example, in a monopoly market, where the cost and profit functions are quadratic, we should always consider where the profit is maximized or where the cost is minimized. If we have the function in standard form, f of x equals a times the quantity x minus h squared plus k, the vertex is hk. Notice that this is just an xy coordinate of a point on the graph, where k tells us how high or low to go to the point, and x equals h, so that's how far left or right we need to go from the origin. So the vertex is the highest point on the graph if a is less than 0, and it's the lowest point on the graph if a is greater than 0. So the reason for this is when a is positive, you have an upward opening parabola, and when a is negative, you have a downward opening parabola. So your maximum will exist at the top of a downward facing parabola and at the bottom of an upward facing parabola. This would be a min on the upward facing parabola, and it would be a max on the downward facing parabola. Find the max or minimum value of each function as well as their domain and range. Let's take a look at g of x equals 3 minus 4x minus 4x squared. First of all, I notice that the highest degree term is negative, so I know my parabola will be opening downwards, and I will have a maximum. Now let's write this in descending order of exponents. And then let's group the two first terms separate from the last one. I need to factor out a negative 4. That gives me negative 4 on the outside, x squared plus x on the inside, plus 3. I now need to do a little bit of sketching to figure out what needs to be my third term inside parentheses. So here's my scratch work. I need 1/2 of b, which is 1, squared. That will give me 1/2 squared, and that's equivalent to 1/4. So I'm going to add 1/4 on the inside. Remember, I multiply that to the number out front that I just factored out. That gives me a negative 1. So if I in effect subtracted 1 by adding this 1/4 in, I also have to add 1 on the outside. Rewriting this so it is in standard form, I will always put the 1/2 in for my constant and plus 4. So this is g of x in standard form. That gives me a vertex of negative 1/2, 4. So that's the maximum. If I want the domain of this function, I know it is all real numbers, so negative infinity to infinity. And the range is going to be from negative infinity, because that's how far down it goes. It just keeps on going downwards. But the maximum, the highest value, is going to be at 4. So this exists from negative infinity all the way up to 4, and you always include the maximum. Now let's look at example B. Notice that h of x now has a 1/3 in front of the x squared. So our function is h of x equals x squared over 3 plus 2x plus 7. I'm going to group the 1/3 x squared plus 2x separate from the plus 7. Then I need to undo this 1/3 in front of my x squared. That means I need to multiply the first two terms by 3. When I do that, I will be able to bring my 1/3 out front. My x squared plus 6x will now be inside, and plus 7 stays outside. Notice that if I were to distribute this 1/3 back in to the x squared and the plus 6x, I would have 6x over 3, and that would still reduce to 2x. So in effect, factoring out a 1/3 is kind of the opposite of factoring out a whole number. I now need to find the third term, so I'm going to create a little scratch paper over here and work out 1/2 b squared. That gives me 3 squared, and that equals 9. So if I add 9 inside and then I multiply it by the 1/3, I get 3. So this is in effect adding 3 to my expression, which means I also need to subtract 3 on the outside. I also know that when I rewrite my binomial squared, I will have 1/3 x plus 3, where 3 is always the number inside the parentheses before I square it. And then 7 minus 3 is 4. So my vertex is at -3, 4. And since my leading coefficient on h of x is positive, I know my function is opening upwards, which means that my vertex is at a minimum. The domain of this function is -infinity to infinity. And my range will be from 4 to infinity.